everyone, this is Mrs. Jackson, and this is part 1 of Chapter 1, Section 6. We're skipping Section 5 of the chapter this year, so we're going right to 6. In part 1, we're going to solve a system of equations and then a system of inequalities by graphing. This should be total review, but what I'm really focused on this year in Algebra 2 is solving a system of 3 equations, 3 unknowns, and as a preface to that, I just want to review 2 equations, 2 unknowns. Okay, let's get started. I have a system here of 2 linear equations that I want to solve by graphing. If you recall, we're going to graph these 2 lines and then look for the point of intersection, and that value of x and y are going to be the 2 values that satisfy both of these equations simultaneously at the same time. Okay, so I want to get both of these in a form that I can graph them. So I'm going to start with the one on the top here. And I'm going to put that in slope y-intercept form, which means isolate the y. So if I want to isolate the y in this equation here, I'm going to subtract, first I'm going to subtract that 2x off of both sides. And then I'm going to divide everything through by -3. And that'll turn this into a positive 2/3 x. Whoops. And -1. So our slope here is 2/3, or rise of 2, run of 3. And our y-intercept is -1. Next, I'm going to get this into slope-intercept form by isolating y. And all I need to do is subtract that x from both sides. So in this equation, my slope is a -1. And always slope is a ratio. So if it's an integer like this, it's really -1/1. And our y-intercept is +4. All right, how do I graph these? I'll start with my red here. So I've got +4 up here for a y-intercept, and I'm going down 1, run 1. So, and I just repeat, down 1, run 1, down 1, run 1, and I end up with my line taking form. And then I could just draw my line through these points. Didn't do a great job of that, but you get the idea. All right, and now to graph the other, I've got a y-intercept of -1 and a slope of 2/3. So from -1, I'm going to rise 2 and run 3 and just keep that pattern going. Rise 2, run 3, and again, I'm going to make a line through this. And you can see the point of intersection right here is 3, 1, or x equals 3, y equals 1 will be our solution. And just before we move on to inequalities, I just want to point out that if you had 2 lines that did not intersect, that would mean they're parallel. That is the definition of parallel lines on the same plane. And in which case, with no intersection, there would be no solution that would satisfy both equations simultaneously. Likewise, if you had lines that are superimposed on top of each other, then you would have an infinite solution. So any point along those lines that are superimposed, any x and y pair that are on those lines would be a solution. So you'd end up with an infinite solution. All right, great. Let's move on to inequalities now. So on this top inequality here, I have x plus 2y is less than 8, and same thing we did before. I want to get this into slope-intercept form, so I'm going to subtract x from both sides, and I'm going to divide both sides, that means all terms, by +2. Now remember, if I'm ever dividing or multiplying an inequality by a negative number, I would have to change the direction of this symbol, but I did not have that here. All right, so our slope here in this inequality is also linear. I'm going down 1/2, and my y-intercept equals positive 4. And I'm going to take this inequality and I'm going to do the same thing. Get this into slope-intercept form by isolating y. In this case, all I have to do is add 1/2 x to both sides. So I end up with y is greater than or equal to 1/2 x plus 2, where our slope equals a rise of 1 and a run of 2, and our y-intercept is positive 2. All right, I will graph the red first. So I've got a y-intercept of positive 2. I'm going to run 1 from that point. Rise 1 and run 2. So I end up with my graph taking form here. And I can also go in the opposite direction, go down 1 and left 2. And I'm going to draw my line. Now, one thing to note here is that our y is greater than or equal to this particular line. And so because of that or equal to, I am allowed to draw my line. I'm going to draw my line in a solid form. So I'm just going to keep going here. Now we are greater than, our y, our output is greater than this line. And so I just want to make a note here. Whoops. I want to make a note that we're looking for values that are above the line. All right, great. And for our blue inequality, I have a y-intercept of 4 and a slope of -1/2. So I'm going to start here at 4, and I'm rising down. So down 1 over 2. Oops, I end up with a weird blue. Keep the pattern going, and I can go on the left side, left 2, up 1. Okay, now on this one, we have a less than symbol, and it's not less than or equal to. So the way we show that in graphing form is it's like an open circle where we would use for a point, but in this case, since I'm graphing an entire line, you're going to graph that line using a dashed feature to it. So that tells our eyes that the entire line is an open circle, if you will, every point on that line. And our inequality was less than, so we're looking for outputs that are below this blue line. So what are our solutions to this inequality? Well, our solutions are infinite. We are looking for the values that are greater than the red line or equal to, and less than the blue line simultaneously. So I'm going to try to highlight that here with my highlighter. So we're looking for the overlap of the two regions, if you will. So everywhere in this yellow is going to be a solution, and that yellow is going on infinitely towards the left. Now, any point in that yellow region is a solution. However, no points on this dashed line are a solution, since that's an open circle. Every point on this red right here, up until and including that intersection, is also a solution. All right, so the big takeaway here is graphing is a great way to find the solution. However, it is limited. And it's limited because inherently when we read a graph, we're estimating. So if you solve by graphing, we really have to consider it an estimate unless the intersection is integers, as we had in the example 1. If it's a fraction, if the two lines are intersecting at some fraction, we would not be able to identify that solution with any kind of accuracy. So this is a great method, but it is limited. All right, I hope this review helps. Thanks for listening.